Hello everyone. Today I'm going to make a presentation on chain rule as I teach in Calc 1 class. In my class I teach using a document camera, and I record my lecture and post it on Brightspace Learning Management System. So I'm going to imitate the same methodology so you get an idea of how I teach in my class. So the topic of the presentation today is chain rule. Okay. Now it is believed that the chain rule was first explored by Newton and Leibniz, and there is also a source which says that the chain rule was explored in a detailed fashion by Lagrange in his work in 1800s. I don't know which one is more correct and which one is less correct, but let's just attribute the development of chain rule to all the three great mathematicians. Now let's consider the function u of x, and we write it u of x as f circle g of x, or it is written as f of g of x. From our knowledge of college algebra, we know that this is not fog x, it is f circle g of x or f composition g of x. And from our knowledge of college algebra, we know that this function is always evaluated inside out. That means it's you evaluate the function g at x first, and then you evaluate the function f at gx. Okay, and we also know the order methods. In other words, f circle g is not the same thing as g circle f. In other words, the composition is not commutative. We also know that the domain of the function u is the same as the domain of the function g, and the range of the function u is the same thing as the range of the function f. Now, in order that the composition is well defined, we want the range of the g to be completely contained in the domain of the function f. If the range of g is not contained in the domain of the function f, then the composition is not well defined. Then we will not be able to use the chain rule of differentiation. Now, visually speaking, I mean, x is the input for the function g, and then what gets out is the function g of x, and remember, this is the range of the function g, and this becomes an input for the function f, so that it means it is the domain of the function f, and what gets out is the f of g of x. In other words, that's the range of the function f. So in order for the composition to be well defined, we want the range of the g to be completely contained in the domain of the function f. Otherwise, the composition is not well defined, and we will not be able to use the chain rule of differentiation. Now, when you want to use the chain rule of differentiation, what do you get? I mean, u prime of x is nothing but f prime of g of x times g prime of x. So this is the derivative of outside function evaluated at the inside function times the derivative of the inside function. I repeat again, the derivative of the function u is nothing but f prime of gx times g prime of x. In other words, it's the derivative of the outside function evaluated at inside times the derivative of the inside function. Here, of course, you have two things. One is the outside function. The outside function here is the function f. Then there is also an inside function, and the inside function is the function g. So the chain rule states that u prime x is the derivative of outside evaluated at inside times the derivative of the inside function. Now let's go ahead and quickly demonstrate an example, or let's see how we use a chain rule for a particular example. Consider the function u of x is equal to e to the negative x squared. Now it is very clear that you cannot use the power rule of differentiation for this function. You cannot use the sum rule, you cannot use the difference rule, you cannot use the product rule, you cannot use the quotient rule. And if you want to find the derivative of the function u using the limit definition, it takes a very long time. So it gets complicated as well. So also you can realize that there are two functions here. One is the function outside function f, which is nothing but exponential function, and the other function g is nothing but negative x squared. Okay. Now the derivative of outside function is in other words, exponential function. The rough sketch of the exponential function is like this. So the domain of the f is the run of the function, which is negative infinity to positive infinity. Now g of x is a parabolic function, and the parabola is opening down because of the negative sign. So you get the rough sketch of the graph is going to look like that. So the domain of the g is going to be what? The domain of g is going to be negative infinity to positive infinity from the graph, and the range of the g is going to be the least y value possible is negative infinity, and the highest y value is 0. Okay, so you can clearly see that the range of the g is contained in the domain of f. Again, I repeat, the range of the g is contained in the domain of the function f. So because the range of the function g is completely contained in the domain of the function f, the composition is well defined, and we can use the chain rule of differentiation to differentiate this function. So using the chain rule, what do we get? We want to find a derivative of outside evaluated at inside. So the derivative of outside f prime is going to be the derivative of exponential function is exponential function itself. We know that from our previous classes. And the function of the derivative of inside function is we're going to use the power rule of differentiation. So you get negative 2 times x to the 2 minus 1, which is going to be negative 2x itself. So now when you use when you see the chain rule, it is the derivative of outside evaluated at inside times the derivative of inside. So derivative of outside evaluated at inside, so you want to put it right there. The derivative of outside evaluated at inside times the derivative of inside function. So u prime of x is going to be nothing but e to the negative x squared times negative 2x. Now usually the way I write it is a sign first, so that means I write the sign first and then the number next. So I write that number. If there is a radical of a number, I write it next. There is no radical here, so I'm not going to write that. Then I write the variable, which is going to be x e to the negative x squared. Then if there is a radical of the variable, I write it after that. There is no radical of the variable, so I don't write it here. Okay, this is how we use the chain rule to find the derivative of the function e to the negative x squared. Now let's quickly recall a few things. And what did we do? We defined what is the we went through, we discussed the origins of the chain rule, and then we quickly stated the composition function, and we recalled a few properties of in which we recalled the conditions under which the composition is well defined. We gave a graphical representation to it. We stated the chain rule, and we identified what is the outside inside functions. We showed that how the range of g is contained in the domain of the function f. We evaluated the derivatives of outside and inside functions, and using the chain rule, we evaluated the derivative of the e to the negative x squared. So the derivative of e to the negative x squared is going to be negative 2x e to the negative x squared by the chain rule. And we also showed how we were not able to use power rule, sum rule, difference rule, product rule, and quotient rule. And to use the limit definition, it will be very difficult, so we did not use it. Now, a few key things that you need to you can realize is that the graph of the function u of x is a bell-shaped curve. You can look at it. So it's going to look like this. I mean, this is a rough sketch. Please don't hold me to the scale. The domain. So the domain of the u is going to be a run of the function, which is going to be negative infinity to the positive infinity, and the range of the function u is going to be the rise of the function. So it is going to be 0 and 1, and you see the graph gets very close. The x-axis is the asymptote here. X-axis is the asymptote here. So the graph gets very close to the x-axis. It does not touch the x-axis. It does not cross the x-axis. So we can recognize that the domain of the function u is negative infinity to infinity, and the range of u is 0 to 1. This is a very, very important function. I hope you will see it again in the future. I'm pretty sure you will see it again in the future as well. Now, and now there is another important application. There is another important connection to connection of the chain rule to the u substitution. Some of you may be familiar with it. Some of you may not be familiar with it. After you learn the derivative of the derivatives, implicit differentiation, derivatives of inverse trig functions, derivatives of hyperbolic functions, and how to find maximums and minimums using derivatives. After that, you're going to learn integration, and there are several integration techniques, and some of you might know it that the integration and derivatives are opposite processes. There one of the techniques of integration is u substitution. So the derivative of e to the negative x squared is negative 2x e to the negative x squared, and integral of negative 2x e to the negative x squared is e to the x squared. And suppose if you want to find the integral of it, you want to use a u substitution, which is in a sense it is the opposite of the chain rule. So that is one of the important application which you will study in this course itself. I mean, which you will study in this course itself. So it is a very, very important section. I hope you learned. I hope you understood this. If you have any questions, I will be more than happy to answer it. Now that is my end of the presentation. Now there are a few things, like I don't go in such a uninterrupted fashion. I go slowly and I invite questions. I hope to involve students in a dialogue while doing this problem, because if I otherwise it will look very monotonic and students may not even understand it. It is very important to have the interaction while doing this problem, which I did not do it while presenting. And the second thing is I also demonstrate the proof. At least I give them the outline of the proof during the lecture, or in the lab time, or in the office hours, one of them. I did not do it because of the want of the time. That is how, this is basically roughly how I teach it in the class. So I hope you like my presentation and I look forward to your feedback. Thank you for the opportunity once again.